Now we have an AI that has 3 different states. One of those states is to patrol. Actually, it's 4 states. So he's got a patrol state. Then he's got a reaction state where he's reacting to an enemy that just entered their radius. He's also shooting at that enemy when they enter the range radius. And then if they enter the melee radius, he moves up to them and he hits them with the melee or jumps. So if we move out of here, we get hit with the ranged attack. And then if we move out of there, we're not getting attacked, but they know and we know that they can see us. We move out of here, he just goes back to patrolling. Yo, what is good, dev guys? It's your boy King. Yes, sir, I'm back with another video. In this long video, I want to show you guys just how powerful state trees can be for your own projects. Jumping into this documentation here, we're in the Unreal Engine documentation website. We have the state tree overview. It says here that state tree is a general purpose hierarchical state machine that combines the selectors from behavior trees with the states and transitions from state machines. Users can create highly performing logic that stays flexible and organized. These 2 keywords, big. State trees is very flexible. I've been working with it for the past week and a half, 2 weeks. Using it for my own project, and every time I had an issue, I was able to figure out a way to mold state trees into a way to solve that issue. Organization is a big thing for me. One of the biggest reasons why I can't use behavior trees is because of the way that they can get when they are, very complex. So organized is a huge keyword for the power of state trees, and not to mention that they are highly performant based on the way that the state tree logic flows. So I want to show you guys a real world scenario for a state tree. This is my game Baseline. This is a first person basketball game. If you have not seen my first devlog, check it out. I have a state tree here that is a simple state tree that is a part of a bigger chain of state trees. This one swaps in whenever the player has the ball in their hands. So when the AI bot has the ball in their hands, they enter this ball handler state tree, and essentially they do a free roam here. And once that free roam succeeds, they check for an opportunity. This basically means that they move to a position and then they go and they delay, which is what this check opportunity task does. They delay. This is just to make sure that they're not doing everything too fast so I can't debug it. And then once this delay task completes, it transitions to this make a basketball play state here. And in a make a basketball play state, the AI is looking at the goal and then they're checking for a shot opportunity. And depending on some variables coming from the outputted data from this custom task to check for a shot opportunity, we are either transitioning to a pass, to a shot, or we are trying to move to find some better spacing to run this logic over again. And you can see here that you have like these specifiers showing you how the logic is flowing. You can see that this arrow points to execute pass, this arrow points to delay. There's a check mark here with an arrow, and all these things have their own meanings, and we'll go over them in detail whenever we start the tutorial. But I just want to show you this in action and show you how easy it is to craft some pretty complex logic in a state tree. So right now my AI aren't running anything. They don't have any state trees assigned, and I'll go into full screen so this looks better. Once I pick up this ball, the defense will play defense and the offense will start playing offense. So I'm gonna try to get this guy the ball here, and I did not land that pass because I'm doing this in real time. This is not rehearsed. I'm gonna actually call a play here so I can get them moving to a specific spot, and I see him going to the corner there. Hopefully that pass makes it. It did not. Jesus Christ. Once they are the ball handler, that dude shot that instantly. But usually they take a little time to decide. You can see that's what he's doing. He's moving to space. He said, "Oh shit, I'm open," and then he shoots the ball. And the AI shot is automatic. You dig what I'm saying? So that's just a simple state tree for whenever the players have the ball in their hands. I can get more in depth, and I do plan on getting more in depth with their logic. I want them to really think like a basketball player. So enough talking. What we're going to do first is regurgitate a tutorial from the documentation. And this is only so that we're all on the same page. You might have seen this. You might have done this yourself. Maybe you've never seen it. So I just want to make sure that we're all on the same page. We all have the same understanding of the basics of state tree. And then we'll get into the more advanced stuff. We'll try to get all this done in one video. If it feels like it's taking too long, I might split it up into 2 videos. So just be prepared for that. But we're going to jump right in. I'm gonna move this over to my other screen. And like I said, I am following for this entry here. I am following this documentation's quick start guide, which is just to get you introduced. If you've already done this, or if you just want to skip it, you could go ahead and just skip to the next timestamp. I'm gonna close this project down. I've already started to preemptively create a new project. So I want a first person template. I want to make sure it's C++ because we will be diving into the C++ side of state trees. So I'm going to save this in my D drive, and then I'm going to create this, and I'll see you guys in a sec. First thing we need to do is go to edit plugins and type in state tree. And you guys need to activate state tree and the gameplay state tree plugins. This will prompt you to restart your projects. Okay, with that started back up, we're going to jump right into the state tree quick start folder here. Right click and go to artificial intelligence and go to state tree and then component schema. These schemas, they act like a filter. That's essentially what this does. It will only reveal to us classes that are accepted by the state tree component schema. So I'm going to go ahead, select this, and we're going to call this ST shooting target. With that created, I'm going to go ahead and right click and create a actor class. And this is going to be our actual shooting target actor. And this will be the actor that actually has the state tree component and runs the state tree. So we need to come in here, add a state tree component. We can fill in our shooting target state tree there. And then we also want to add a cube, which I see there. And we want this cube to be 0.2, 2, and 2 in the scale, like that. Then with this cube, we want to create one of the delegates here for the on component hit. Just create a callback for it. And whenever it's hit, we want to increment a variable called hit count. This is going to be an integer. I'm going to drag this out, holding control and increment. And this will just increment this value here for us. Going back to our state tree, we want to first off inside of this schema, it should be closed for you. But if you drop down, you have an option to set the context actor class. You could leave this at actor, but you won't have access to private variables or specific variables that are on actors like this shooting target actor. So what we're going to do is pass it the shooting target actor because we know that this state tree will only run on this actor here. This context is essentially instance data for the state tree. It wraps the context actor, it wraps the state's running status, and it wraps all of the output and input variables in an instance struct that it makes it all accessible inside of the state tree. When we come over here, we need to create two states. This needs to be idle, and we need to have a dead state. In the idle state, we'll create our first transition. So over here, you got interconditions, tasks, and transitions. We'll focus on transitions here. Basically, the transition is what rules will make this state exit or go to a specific state. You set those rules using the transition. You have a few here where on state completed, on state succeeded, on state failed, on tick, and on event. All of these are useful for controlling the flow of how your state tree should react so that your AI never really gets like locked up. So on state completed, we're going to go back to the root, and then we're going to add another transition to check on tick whether or not we should go to the dead state. And that's going to have a condition on it that's going to compare our integer that we set on our actor here, hit count, and we want it to be greater than or equal to this value we pass in here. So every time this state tree takes this state, it's going to run this transition right here. And then it's going to compare the value that we bound right here to this number. And if that is greater or equal to that number, it's going to transition to the dead state. And then in the dead state, we want to add a task that will just display some debug text on our actor saying that the actor is dead. And then we'll paint this in red, leave the scale the same, everything else default. And that's our current state tree right now. And now the first thing we do is create our own custom task. And this is going to derive from state tree task blueprint base. This is going to be STT_destroy. And all this task is going to do is simply destroy the actor whenever the task runs. So we come in here, we want to override the exit state. You have these four options that you can override. And it's just like any other blueprint as well. You can create your own functions just to have compact logic. But these are the 4 that are built in to override, and they trigger when the state is entered, when the state is exited, when the state completes, and when the state ticks. Right now, when this state exits, we want to get our context actor, which in order to do that, we need to have a parameter or a variable set to the type or at least the base type that we're looking for. And we have to put it in, make sure you compile, because I've run into some issues where if you don't compile, it won't get saved into the context. But we have to put it in the category of context. This keyword for the category essentially lets the state tree know that we're trying to link this with the context that is a part of the instance data inside of the actual state tree. I prefer this over using the key value map that you have with behavior trees in the Blackboard, where you have to type in a name and then that name then is tied to a type. And then when you want to set that type, you got to get the name, set it by type. And it's just really clunky, but this is really straightforward. All right, so when we exit the state, all we want to do is grab this actor and say destroy actor. And that's essentially what this state is going to do. We can compile this, but I'll show you another trick. If we go over here to the shooting target here and we go to our dead state and we add the task for our destroy, you see how it's just listed like this. And then you can only imagine how unorganized it'll be if you have 500 different tasks that your AI can possibly run and you got to filter through them. You could use a search bar, but one other thing you could do is come over to the blueprint where your task is, go to class settings, and you can give it a display name. So we want to call this destroy actor, but even better, you can give it a category. So it'll give it like a folder structure inside of that drop down. So I'm gonna just call this state tree task. And then there's this key. If you hit shift and the key above your enter, that makes this little OR symbol or half an OR symbol. And we want to just put this as quick start, because all of these tasks will be part of the quick start tasks that we're creating here. And now if we come on over here and try to add that task, you see we have state tree task and then our quick start folder, and then we have destroy actor. Maybe it's just a little bit organized for those of us who have OCD. So we add this task and we need to add one other task to, and we'll drag this above. We'll add the delay task and set it to delay for 2 seconds before it completes. So the way the tasks run is that these run on top of each other. There is no this task first, this task second, this task third. No, these tasks will run a for loop or for each loop over the task array, and then it'll say execute task, enter task, like basically execute task for instantly for all of them in one frame. So it doesn't necessarily matter what order you put these in. I'm just trying to keep it 1-to-1 with the quick start guide. So set it to 2-second duration, and then whenever this state completes, we'll transition to tree succeeded, meaning that this entire tree succeeded and we should stop processing this state tree. So if we save that, we can actually begin to test this. So we can drag this shooting target actor out into the world, just put them there. And now I'm gonna actually go to this first person blueprint here really fast. And let's go to wherever we fire this bullet so I don't have to hear this sound. Where is it now? Oh, they moved it. Oh, they're making things modular now. Okay, it's not in here either. It's in the bullet. All right, I don't know where the hell they got that at. Oh, I think they got a weapon component or something like that. Didn't they have like a weapon component? I don't know where that is anymore. First person player controller. It should be in here. I think all the code is in C++. Okay, no biggie. We'll just deal with the sound effects being trash. So I'm gonna press play here, and I'm going to go pick up this gun and shoot this target 5 times. We get this assert here. I'm pretty sure that Unreal knows about this. This is what happens every time I run this in debug mode. This asserts, maybe because there's an issue with the states being exited before something has processed. But if you just continue through that, it doesn't crash the editor, it just asserts. But you can see that our actor destroyed. So all of the tasks complete. And if you wanted to debug, you could just add a breakpoint right here to this task and see that it does complete. But that's the first little phase of this complete. The next phase is actually creating a spline actor that this actor will follow along. So let's get started with that. First thing we need to do is create a blueprint class that is a actor, and we're going to call this BP spline actor. And then inside this puppy, we want to drop a spline. And then we want to create an evaluator that will essentially get this spline or get a reference to it inside the level. So from inside of the state tree, inside of the states, you cannot access data that is outside of the state tree. So if there's some data from the world, you have to use an evaluator or a global task to cache that data. And then you need to pass that data into whatever task needs to read it or write to it. So what we need to do is create an evaluator, state tree evaluator, and we'll call this STE underscore get spline. And we'll double click into this. And on tree start is one of the functions that we can override. This is when the tree is, begin play, the tree is activated. Tree start will fire on this evaluator, and we can get all actors of class. And we want to get that spline actor. And this is just to allow us to place multiple splines in the world. And then we need to get access to the context actor as well. So make an actor variable of type actor. And then we'll make sure to put this, I'm gonna compile and make sure to put this in the context category. Then we can pull off of this and get this actor's location in the world, and then find the nearest actor to this origin point here. And this will return a value for us, and we'll actually set this as a variable for the spline actor. And for the first time, we'll show an output where this evaluator will output data that can now be used inside of the state trees. So we'll put this in the output category, compile that, and now we'll be able to access this variable inside of the states. The next thing that we need to do is create and I'm actually going to just duplicate this state tree task here. And this state tree task will essentially tell our actor to move along the spline. And we'll delete this. I just want to keep that context actor here. We also need an input variable. First time we're using that. So we need the spline actor as an input, and we'll just set it explicitly to the type of spline actor. And in order to have an input be passed in, you can do it one of two ways. So I could just make this instance editable, and then I will be able to bind it inside of the state tree. Or if I wanted to make sure that a designer down the line, when they use this task, I want to make sure that they don't accidentally set this to null pointer and crash the engine, I can put this inside of the input category. And this will not allow you to compile the state tree unless you bind data to this input. So this has a little bit of math associated with it, but it's not anything too crazy. But first thing we want to do is make sure that we have our completion point, which is setting this actor's location. And you can see here we're using event exit state, but actually in this task, we want to do it on tick. All right, so on event tick, we want to set our actor's location, and we're going to use that spline. So we're going to grab this guy and we're going to get the spline. And then we're going to grab the location at distance along spline. And then this distance variable will pull out and promote this to a variable. And any variable that I don't want to be accessed outside of this evaluator or task, I will set to private, just so that it's not accidentally bound to or read inside of the state tree when we don't really want it to. We want to set this to world, and then we want to pass this location in as the new location. Wow. What's this? The property associated with spline. Let me go to my spline actor and compile it, because that's the reason that that's having an issue. Okay, so after we set this actor location, we want to check our distance here, and we want to check its value against the total distance of the spline. So I'm gonna grab this spline again. Oops. Grab this, Control D, and then we want to get spline length. And if this distance is less than this spline length, we want to do a couple things. So go here. The first thing we want to do is set this distance. So we'll add some speed to this distance. Promote this to a variable, call this movement speed. And they don't do this in the tutorial, but you can set this to instance editable, and you can make this a variable that you can mess with inside of the state tree. So I usually do that, and I put it in a category of settings so that it's in its own little category. By default, this is set to 5 in the tutorial. So we'll set this distance equal to distance plus movement speed. So I need to grab out and grab a set node here. Pass this in there. And then if this is false, we'll set distance to 0. Once this is set to 0, we'll tell this task that it's finished and also that it has succeeded. Once that's done, we can actually use this task, but let me change the name of it really quickly. We're going to keep it in the same category, and I'm going to call it move along spline. And we can even be more explicit. We can say move actor along spline. And let's close some things down. Let's close all these tabs to the right. And let's go into the shoot and target state tree, and we can add a state to this idle state. And that actually added a state to the root state, but we want to delete this state. Right click on the idle state and add a child state to it. And we'll call this move along spline. What we want to do is have a task that moves this actor along spline. And here's that error that you'll see if you try to compile this without binding an input to the spline actor. It'll say, hey, it's expecting to have a binding. But you can also see the value that I set to be instance editable right here. I can bind this as well. I can bind this to net priority or whatever variable we want to say is our move speed. But in this case, we want to bind this to, it's not letting me bind here. That's probably a bug. Let's delete this and add it back. So move along spline, and then can I bind this, please? Can I bind it, please? Okay, I think I know what the problem is. So I'm gonna compile it without that and then add it back here. Sorry about that. Move along spline. We should be able to bind this. Why am I not able to bind this? Oh, you want to know why? Because we don't have anything to bind. So it's thinking, hey, we don't have anything to bind that is outputting a spline actor. So this thing is actually pretty smart. So if I go to this evaluator, which I created this STE get spline, now we have this output for a spline actor. We output it as an actor, but we want to output it as a spline actor. So we did something wrong in here where we get the spline. Oh, of course, we need to cast this to a BP spline actor and then set this variable. And we can actually just change this to BP spline actor. Object reference, change the type. My screw up there. So compile that, and now we should be able to grab. We got to refresh this. So delete, add this out evaluator back. There we go. Now we should be able to drop down. Huh? What? Okay. All right, let's try this again without all the mess ups from me. So move actor along spline. Now we can bind it to the spline actor. Phew, Jesus Christ. That is not a good representation of how clean this is. I kind of messed up there. But now what we'll do is, since this state is set to try select children in order, this state will enter and then it will also pass it down to its child to process the child. Now we can compile that and we can actually take our spline actor, bring it into the world and give this guy a path that we want it to follow here. I'm going to go up here. Let's go back here a little bit. Go over here, go over there, go here, go down, and we'll bring it back over here and we'll come to the spline and say that it's a closed loop. And if we save that and hit play, our actor will start following our spline. Another thing that we didn't do correctly is in the shooting target, we want to set this value on the Z to be 100, I think, or 50. So that it's sitting above the origin, so that the origin is at the bottom. So now we have this target and we could try to hit it 2, 3, 4, 5, and it stops moving and then it destroys itself. Whatever bug that is, that's something that occurs even with Unreal Engine's tutorial. So in all honesty, that is a good introduction for us to actually get started with our own custom state tree component, our own custom schema. We're going to dive into the C++ side. We're going to dive into the blueprint side. We're going to do a good balance of both. So I'll see you guys in a sec.
Okay, so in order to move forward with the rest of this tutorial, we need to add a feature or a content pack here, and we need to add this third person feature content pack. I might just add the blueprint version. We just need this blueprint actor. We don't need any C++ from it. So we'll add that. It comes with some inputs and whatnot, but we don't care about that either. So the way that this could work is that we could create a state tree for our AI, and then inside of that state tree, we can add a state, and actually more realistically, we would add a sibling state to the root, and this would be our patrol state. And then we would work inside of here with child states like look for next location, move to next location, pause at next location. You would do all that inside of the same state tree that we would already have. But I hope you can see how that could create an issue with it being a monolith. And what if you want one of your AI to only patrol? You don't want them to move along a path. Or what if you want your AI to only react to whenever a player is in their vicinity? You don't want them to patrol. So you don't want to have this monolith of a state tree and some of the states aren't even being used. Also, a big thing is that as you increase the data that's being outputted, inputted, and referenced inside of the state tree size starts to increase as well. My suggestion and what we will be doing in this tutorial series is making this a modular system where each state tree is handling a state. And this allows us to have complete control over which state is actually executing. We get to control the exact flow. We don't have any collisions with the flows by putting them in the same state tree. For example, if I wanted a tree to exit whenever the state finished, I couldn't do that whenever I would make a monolith because it would actually exit the entire state tree. And what if I wanted the tree to exit and then move on to another state? So for me and for my project, I just think it's better to do it modularly. If you want to do it in a monolith, you can easily do what I'm doing and put it all inside of one state tree. But in this tutorial series, we will be doing it the best way that I believe you should be doing it, is using modular pieces. That way we're using composition over inheritance. So what we're going to do is create some custom C++ classes. We're going to make our own state tree schema. We're going to make our own state tree component. So let's just move over to C++. You see here, I'm in the games folder, state tree course, and in the source folder under state tree course, they don't give a fuck about organization in here. I'm not going to let that bother my OCD. I'm going to create a public and a private folder inside of here. And then inside this public folder, I just want to create another folder for state tree. And then inside this puppy, this is where we are. We'll start creating our components. So I'm going to call this our state tree component. And this is going to derive from state tree component. All right. If we hit OK on that, if you are using Rider or if you're using Visual Studio, you will have a squiggly underneath this. The error is that you have not included the module to be able to use this in C++. If you are struggling with these errors in Visual Studio, I suggest getting Rider, because Rider will tell you explicitly what you need to do. And also, if you press Alt Enter, Rider will do it for you. I don't have the squiggly here because I've already included the module, and de-including the module probably takes time to do. But essentially what I have here, this gameplay state tree module, this is where the state tree component is actually located. So in order for us to use it in our code, we have to include it. Unreal, include what you use. Okay, so go to your state tree course, build.cs, or whatever your project name or plugin name build.cs file is, and add this gameplay state tree module to the public dependency module names. You can also add it to the private dependency module names as well. It should be fine. So yeah, with that, we'll have our state tree component. Then we want to go into this folder, create another class, and we want to create our own state tree schema. And this is going to derive from the state tree component schema. We want to use the state tree component schema because we want everything that the state tree component schema has. And then if we want to add on to that, we'll override some of the public virtual functions, and I'll show you what those functions look like here in a second. So if we control click into this state tree component schema class here, we have this virtual bool is struct allowed, is class allowed, is external item allowed. This allows us to say, okay, this state tree is allowed to use this type of condition, this type of evaluator, or this type of tree task. So if we wanted to create our own custom tree tasks with our own processes and our own overridable functions, what we would do is inside of our state tree schema class, we would override this is struct allowed, and we would basically copy and paste this and add one more line here to say, or our new class, right? You have a lot of flexibility with how this state tree will operate based on this schema filter. So currently we're not going to override anything inside this class. We just want to have, we do want to do one thing. We do want to take this uClass specifier so that we can just, have the same thing that is happening here, but we want to give it a different display name. We'll call this our state tree schema. In this way, we can see this custom name inside of the editor whenever we drop down and add a schema here. Currently, this is all we need in C++ right now to get started. Our patrol state is going to be fairly simple. These are the only classes that we need to add, but we do need to go to our state tree component, and this is just for the future. In our state tree component, we need to create a function that will allow us to dynamically change the current state tree at runtime. In this public section, we want to have a U function that is blueprint callable, and we put it in the category of state tree, and this is going to be void set state tree, and we're going to take in a U state tree pointer, and we'll call this in state tree. And in this function, all we want to do is grab our state tree ref, and we want to say set state tree, and we want to set it to the in state tree. And then we want to initialize this component. And now at runtime, we can call this function whenever we want to change the state tree. So if we want our AI to go from patrolling to reacting, or if something that happens along our patrol path in our AI causes them to react, we would have the gameplay code call this so that they can go to the react state. The next thing we need to do is just come into here inside of our folder structure, and let's make a folder for our patrol state tree. And in our patrol state tree, we're going to need a new state tree. And you can see that none of our schemas pop up, but I'm just going to use the state tree component schema for now, because we're going to recompile the editor in a second. So I'm going to just call this state tree patrol. So I know that we want to do a few things. We want to look for next position. We also want to move to next position. And then after we move to next position, we want to delay. And then after we wait delay, we'll look for next position, move to next position, wait delay. And this will go on a loop. So the other thing we want to do is actually go to our newly added third person blueprint here. And we just want to give this guy a state tree component because we know we want him to run the state tree. And don't worry, don't fret. We'll change all of these classes to the classes that they need to be. Oh, actually, if you do this in Blueprint, you cannot do what I'm about to do. I'm so used to working with C++ components. If it's a Blueprint component, you see how you don't have the option. But if it's a C++ component, you have the option to change the component class. You can't do that if it's a Blueprint spawned component. So I'm going to delete this. And then we actually do need to recompile the editor to move forward. So I'm going to compile this, and I'll see you guys in a sec. Okay, this is very simple to fix. Let's take a look at this first error here. You can see it's about the brain component. It's talking about e resource is locked, or is resource locked. And it says that the symbol is unresolved. This is usually an include issue. But if we go to the class, the uBrain component, we see that this class is located in the AI module. And once again, Unreal, you have to include what you use. So if there's something referenced in the AI module, you need to include the AI module in your build.cs file. So let's go over here, comma, AI module, and then recompile. Okay, now we're getting this use state tree schema, allow enter conditions. So this must be another module that we need to include. So the state tree schema is in the state tree module. You see that? So this is in state tree source state tree module. This means that it won't be included unless we include. And this is where I like to do these like this. So that's easier to read. And now we need the state tree module. And now we should be good to go. All right, now that we have the editor open, let's go ahead and go back to our patrol state tree. And let's change this schema to our state tree schema. Nothing should change because it just inherits the state tree component schema. The next thing that we want to do is go to that third person blueprint. And let's give this guy a state tree component, but let's give it our state tree component. And let's go ahead and give him the patrol state tree to start out. Compile that. Essentially how the patrol is going to work is that we're going to use a spline actor as well. We could do this two ways. We could query the world using like an environment query, or we can do a random patrol or a defined patrol. So in this case, we'll just use the same spline method since we've already learned that. And we need to see how we can put this to use. But essentially this spline could be used as a patrol route, right? So let's go ahead and create our own actor for the patrol that is essentially just the same as this spline actor right here. So I'm gonna just copy this over here, and we're going to rename this to BP spline patrol actor. And we're going to essentially mimic what we did in the state tree, but use it in a way that's not driven for this moving target. So looking for the next position will require us to query a location on this spline. So let's go ahead and make this evaluator over here. I'm gonna just copy this guy. We will rename this guy to get patrol spline. And you'll see that a lot of things in Unreal require this type of work where it's like, okay, here's something that I need to use, but I don't want it to be exactly like that thing, but I don't want to lose what that thing has. I myself do a lot of copying and pasting, and as a programmer, don't feel bad if you do a lot of copying and pasting, because I mean, there's rarely any code that hasn't been written yet. So this spline actor is cast into the BP spline actor, but we want this to be the spline patrol actor in this way that this doesn't get in the way of the spline actor. So we need to cast this to a BP spline patrol actor here instead. All right, so almost in the same position as we were when we were doing the quick start. So now we're able to get the patrol spline. Call this get patrol route. And let's actually go to the settings and give this
a category of state tree tasks, and let's call it patrol. And this is going to be find patrol route. Okay. And we also want this state tree task to move along the spline, but we don't want to do it the same way that they're doing it for the actor. So I'm going to copy this guy. Let's rename this to move to patrol point. All right. So on event tick, we're moving along the spline at a constant speed every frame. In this case, well, first off, we want this input to be a patrol spine. Change this variable type, refresh. Okay. So a lot of this logic is pretty wrong. We actually want to use a task for this, and we don't want to do it on event tick either. So we'll get rid of that event tick. And whenever this state has entered, this is when we want to run this logic. So we're going to have an issue with the spline here. We don't really care about the movement speed here because the movement speed is set in the character movement component. Oh, hold on. Let me just delete all of this. We can get rid of this. We probably will still need the distance, but maybe not. So this spline actor has points along it. What we want to do is get the point at the index and get its location. So let's look for the get location at spline point. So here is our spline point that we want to get a location at. So I'm gonna set this to a variable. This is the next patrol point. And what I'm gonna do is I'm gonna make this private because this next patrol point, we're going to randomly select it whenever this state has entered. So we'll get the spline here in the beginning as well. And we want to get number of spline points. So this is the number of spline points. And we want to get a random number in between the number of spline points and 0. So this is not 0 based, but whenever you get a spline point, it is 0 based. So I'm going to subtract 1 from this so that we don't run into a error with the array being out of index. So whenever we enter this state, we'll set this value to a random number, and then we'll get that value in world space. So we can delete this. That means we can also delete this. We'll get that value in world space. And then what we want to do is use a simple move to. Now here, the simple move to location, it requires a controller. We know that our actor that is running this state tree is this BP third person character. So what we could do is grab this actor. We can cast it to a character. You don't have to cast it to the BP third person character. All we need is the controller. And this should be an AI controller, but we'll just pass this controller in. We're expecting it to be an AI controller. And essentially we'll set that point. We'll cast to our character. And when our character is successfully casted to, we'll move to this location. And then we will set this task to be finished. So this will work, but you'll see some issues where the task will finish and will stop moving, or the task will finish and another task will run and we will still be moving, but we won't know when we've stopped moving. So there is also a move to task that's asynchronous. You can also run this. So this is the pawn that is going to run the AI move to. So you could pass in the character here, and then you can pass in the destination here. And on success, that's when we will finish the task. So this will finish this task whenever we have successfully moved to our location. Let's go ahead and use that one. Compile this guy. And now we have our move to patrol point. And this also is finding the patrol point. So what we could do is name this find random patrol point and move. And we're putting this in state tree task patrol, and we'll compile that, save it. Essentially, we no longer need this right here. So we can actually remove this task right here. So, or the state, I'm gonna delete it. And I am going to use my newly created task to find random patrol point and move to. But before I do that, because I know that it causes issues, I'm going to pass my evaluator in here. So find patrol route, we'll have this guy there, and then we'll go ahead and use our find random point and move to task. and then we'll bind our patrol route to our find patrol route spline actor. Then we'll wait delay. After this goes here, all that's going to do is do a delay task, and we want to wait for maybe 3 seconds. We can give it some random variation in here, so 0.25 a random deviation. And when this state has completed, we'll go back to the root. So when this state is completed or succeeded, we'll go to the wait delay. And if it fails, we'll go to the root. Okay. So now if we allow our AI to run this state tree, we can have a patrol route. And let me clear some space here. And we just have a clear playing field here that we can mess around with. All right. So I'm going to take this patrol spline actor, and we know that this actor is not going to interfere with this actor because this task or this state tree is looking for a specific actor. So I'm going to start this patrol, and I see that I want to start it going this direction here. So we'll start here. We'll go here, where you can set everything to a 90-degree angle. Oh, what? I'm duplicating the I'm duplicating the actual spline itself. When I should be duplicating this actual spline point. Oh, Jesus. That was about to be bad. Okay, so let's get this spline point and move it here. Let's just have him patrol from this side to this side. But we can also take these points and shift them to weird areas. So if we want this to follow like a path that's awkward, we can do that. We also have access to mess with these tangents. It might just be me. I might be the only person that gets messed up in the head about this type of stuff. Ooh, okay, that looks good. All right, so one other thing we need to do before we have AI moving is actually drop a nav mesh in here. So let's look for nav mesh bound volume. Let's drop this in here. If you hit P, you'll see where it actually is affecting the world. So let's change this value. Oh, we don't want to go higher, but we do want to go wider, and we do want to go longer, so that this whole thing is encapsulated. And then we will bring out our third person actor. Inside of this third person actor, there is an option to auto possess. So auto possess AI when placed in world, and auto possess player disabled. Just make sure that that's disabled so that we don't auto possess this thing. And the AI should essentially take over this guy and start running the task. That's what I'm expecting to happen. But we'll see if there's any bugs and we'll solve them together. So let's hit play. And I don't see my AI moving. So let's take a look at what we're running into. Access none when trying to read property spline actor. It says access none and set next patrol point. So we're running into some null pointers in the next patrol point, set next patrol point here. It says access none in the AI move to as well. So we got a lot of access nones. Let's just make sure that everything is compiled correctly. Yeah, this should be good. Move to, oh, I know exactly what the problem is. Okay, so we are getting all actors of this spline actor class, and we're trying to cast it to a type that it is not. So that's the problem here. I did copy this. So we need to actually say get all types of spline patrol actor. Here we go. And that's why we're getting a null pointer there, because I was casting it to something that did not exist for it. So our AI is now moving to random points on that spline. It's waiting for 3 seconds. And then it moves to another section. Now, we could take this a little further and allow our AI to either choose a random point, or we could move along the spline in order of the points so that you can set your patrol up with a point 1, point 2, point 3 style of flow. Now, in order to do that, we would have to work from outside of the task because these actual states cannot maintain a internal state, meaning that I couldn't increment this value and then set it to the next value and then come back in, and then that value would be the current value and then increment that value. So moving along the spline in order of 0, 1, 2, 3 wouldn't actually work only using the tasks. I would have to have a variable that was maintained in the character where they know which point they're on, and they would actually give us that point value inside of our move to patrol point task here. That's easy enough to set up. We could create a Boolean here, says choose random point. And then by default, we'll set this to true. This is the default way that we want this to work. And we also need to put this inside of our settings, and we need to make it instance editable so that we can see it inside of our state tree. So if we want to choose a random point here, we want to bring this out, say if, and what I'm gonna do is I'm gonna restructure a lot of things here. So this is how we are getting our random point. So I'll move this up here and we'll say custom event set random point. Take this, put it here. This is actually performing our move. So I'll do a custom event, perform move. And that's what we're doing here. You guys can create comments if you want. So these things are easier to track and move around. All right. So these will be our functions that will run here. So what I want to do is a sequence. And what we'll do is we'll do this check first. And then here we'll perform the move. Perform. Did I spell it wrong? I did. I said perform move. Jesus Christ. It would be like I didn't even learn how to speak English. Perform move. Okay. And if we want this to be a randomized point, we will say set random point. If not, what we want to do is grab this actor, and we will actually cast it to our BP third person character. And what we'll do is actually allow our third person character to pass us the point. So we'll set it from this third person character. So let's make a function here that will return a integer. So this is our current point, and we want a function that will say get next point. So we'll take our current point, we'll increment it, and we will actually return. We'll make this pure so that it doesn't have any execution pins. But we'll take this point and we'll increment it. And we'll set this to be -1 by default. And essentially what we'll do is get next point here. And we also need a function on the character to refresh our points. And this will just set this back to 0. And the reason I'm doing this is because we don't have access to the spline inside of this character. And in order to keep these things separate from one another, all this is doing is maintaining a point for us that we need to use. And we'll do all the comparison checks inside of the place where we actually have access to the spline actor. So what we want to do is get the next point. And if this next point is less than or equal to our number of spline points, and we actually want to say less than, because once we reach the maximum number of spline points, we actually want to reset. So if this is less than, then we'll use this as our next point. If this is false, we'll tell our character to reset current point. And then we'll set our patrol point to 0. So this will make sure that the point that we are on in our actual character is reset to 0 so that we don't start from the wrong place. It's basically aligning what's happening in this task with the value that our character is maintaining. This function, or this should be a function right here. So let's just move this over here so that's a little cleaner, and we'll make this a custom event. And this event will get next point from character. Whoops. Compile this, and then if this is false, we'll get next point from character. So just to test this out and see that it's running the way that it was running, you can see that we're going to a random point there. We're stopping for 1 second, and we are moving to our next point after we stop. Okay. Now, if we want to move along the spline in order, we can turn this off. And I also will want to rename this task. Let's rename this to find point, because it could find a random point or it could find the next point. And this won't actually show up correctly here, but it's fine. We could refresh it like this and bind this to the spline actor and set this to false. And now let's see if this is going to work here. So he moves to point 0, waits for a second, should move to the next point. And it looks like they're just getting stuck on point 0. So let's take a look on this here. Let's take a look and see what happens here every time that state is entered. So here we're getting the next point. We start at -1. We increment the value and we return that value right there. So the next time we enter this state, we start at 0, we increment the value, and we return. So this is 1, but we are returning 0. Not sure how that is happening. That doesn't make any sense. But I'm going to stop here, and I'm just going to return this value because this is causing an issue. All right, so we should see 0 get returned here. That's good. And the next time we enter that state, we should see 1 get returned there. So let's go. So now this is 1. That's good. But for some reason, he's not moving to 0.1 increment. And it looks like that's breaking as well. So we're asking if, oh, yeah. So 1, we're asking if this is less than the thing that we're actually using here. So I see 3 problems. 1, we need to set this so that we only call it once. And let's delete this guy. Every time this function is called, it increments this value. So let's go ahead and set this to this, and then check this against this. And this should have the functionality that we're looking for. If this next patrol point is less than our number of spline points, we don't want to set it to 0. We actually don't want to do anything. We only want to do something if this is not less than this number here. So once it's equal, we'll go to set this to 0. So let's take a look at the functionality here, see if it's working. So we go to 0. We go to 1, we go to 2, we go to 3, we go to 4, we go to 5, and we go to 6, and we go to 7, and we try to go to 8, but then we go back to 0. So now it's just moving along its path the way that it's supposed to. So that, in a nutshell, is how you set up a patrol for your AI using state trees. It's just a task that handles moving the AI and making sure that we either choose a random point or a direct point. One thing I want to do here is put this in the comment as well, because I will be sharing this project on GitHub. So this will select points in order. So this is how we're going to solve our AI patrolling. And now I want to start thinking about how we're going to have our AI react. This is also a fairly simple thing to set up. Usually in behavior trees, you would be ticking every frame or so, or you'd use a component that would be checking for pawn senses and things or whatnot. You could do that. I won't be showing you how to do that with the pawn sensing component. I'm going to try to keep this as simple as possible. If you want to go to advanced topics, then be my guest. Please also show that in the Discord how you took this simple tutorial and made it more an advanced feature for your game. I would love to see that. But for this case, so that everybody can follow along and I don't have to explain classes in depth, what we're going to do is actually allow our third person character to sweep a overlap that is looking for other pawns. And then once we get that pawn, we'll look and check and see if that pawn is a local controller or if it has a local player controller. If that's the case, that pawn will be set as our target and will dynamically swap to our reaction state. So to do that, I'm gonna just come over here and I'm gonna add a sphere collision, and you can see how small it is. So this sphere collision is basically our reaction radius. Let's set this to something like 500. So we'll react to anything in this radius. We can also go to this collision preset, and we want it to only overlap pawn. This will set it to overlap. Actually, this is okay. They did this completely wrong. We want to set this to overlap only pawn, not pawn. And then it's set to block others' responses. So I want to set this to custom. Let's ignore everything except for the pawns overlap. So this will make sure that this is not that expensive of a collision. It's not sweeping for a bunch of objects. It's just overlapping the pawn. We also want to make sure that we generate overlap events, and this will be active for as long as this AI is alive. And then let's drop down here and say on component begin overlap. The first thing we want to do is cast this to a pawn. We know it's going to be a pawn, but I still need to cast to a pawn so that I can get the controller and check if that pawn is locally controlled, or we could just do it straight off the pawn. We could say it's locally controlled. If this pawn is locally controlled, then we want to tell our state tree component to set a state tree. And I know I made this function blueprint callable. Let's send state tree event. Let me make sure that this function is blueprint callable. It is blueprintable for some reason. This needs to be set to blueprint callable, and we will have to recompile. But essentially, we'll set that state tree to be our new state, our React state tree. Let me recompile the editor real quick, and I'll see you guys in a sec. Okay, so with that compiled now, let's go back in here. And if this is a local controlled pawn, then we want to set our state tree. And we currently don't have the state tree that we want to set. I'm gonna just make a quick test state tree just to test that this is going to work. And then whenever this component ends its overlap, let's go back. So component in overlap, let us set our state tree back to patrol. Let's go ahead and create our React state tree. So I'm gonna make a folder for React, and we're just going to copy this patrol state tree into here, and then we'll rename this to React. In this way, we can delete some of this data. We can delete pretty much all of this. We can delete this guy, and actually delete this task. And we'll just call this log really fast. And in the log, we will do a debug text task, and we'll just say reacting. And we'll compile that, and we'll take that puppy and pass it into here. And this doesn't save on compile. I set that to always, because sometimes if you don't save, you'll lose work. So let's see if when we have this radius turned on, and I actually set this to be hidden in game to false. If you go to the collision sphere and go to hidden in game. I turn it off so that I can just see the collider, just to make sure that I'm overlapping. Yeah, there's something wrong with this text task. I wish it would tell me. Okay, here we should. Our state tree React. Yeah, so something with React is crashing the editor. So I'm gonna stop playing here and see if we can get back. No, we have to recompile. Okay, so the issue that we're running into is the same issue that I ran into with my project. And now we're about to start programming a little bit more than you guys probably want to for this, but it will allow you in the future to have a more dynamic state tree system. So what's happening is, if we go back to our third person character, dynamically, we are saying, okay, if this thing that we're overlapping is a pawn, we want to just set the state tree. The state tree is running its logic automatically, but there's nothing stopping our current state tree from running. So there's a frame where these things are overlapping, and essentially the brain is trying to do two things at once. The first thing we need to do, just to make sure, is check that this other actor is not equal to us as well as is locally controlled. So let's do an and here. This is just a sanity check right here. If that's true, we'll set this state tree. But even with this, we will still crash the editor because the state tree is running, and then we yank the state tree out and put a new one in. And there's a frame where the state tree is still trying to process the old state tree. And I keep saying state tree, but it's the state tree component. There's a frame where the state tree component is trying to process the old state tree, and it's null. So we will crash every time. So essentially what needs to happen is we need to stop our logic from running. So we need to stop our logic, and we need to say transitioning states, stop it, set this state tree, and then go back and restart the logic like so. And we need to do this same functionality whenever we in the overlap sphere as well. This should stop the crash. So now if we move into his radius, we don't get the reacting. Oh, there it is right there. You see that reacting there? So, and you can see that he stopped patrolling. So he's no longer patrolling. When I exit this, he'll go back to patrolling. Now I know that I could have done the same thing with with the same state tree, but I want to show you guys a little more ways to use this, because you might run into the edge case where you want to do a completely different behavior tree or state tree, and you have no idea. So this is a source of how to do that. So you need to stop the logic from running. You need to set the state tree to a new state tree, and then you need to restart the logic. Okay, so now that we have this React state tree working correctly, now we can actually create a task. And I'm just going to copy one of my other tasks here. So I want a task that will essentially rotate our AI to look at the target. So let's go F2 and let's say focus target. And inside of here, we can probably delete all of this stuff. And we'll delete this. We don't need this. This input, we actually want it to be an actor, and this is going to be our target, and we'll override enter state. So when this state is entered, we will cast this to a character, or we can cast it to a pawn. We don't have to cast to a character here. Cast to a pawn. We can get the controller of this pawn, and then we can cast this controller to an AI controller. And in this AI controller, there's a function called set focus, and we want to set that focus to this inputted target here. Now, where is this target going to come from? That is what the evaluator is going to do. The evaluator is going to get the nearest actor closest to us, or we could do this two ways. Whenever we overlap, we could store the overlap actor into this function or into this overlap callback here. We could store this actor as a variable and then access that actor inside of here. Or we could dynamically check every frame for the actor that we are closest to. In this case, we're limited to one actor, and we're also doing two things at once here. What I want this overlap sphere to focus on, this is just our reaction sphere. If something is in our reaction sphere no matter what that thing is, it should turn on our reaction state. When we are in that reaction state, we then need to see, okay, who are we close to? Is it this guy, or is it this guy, or is it this guy? You know what I mean? We want to know what we are close to. So I'm going to actually do this the other way, where we use an evaluator, because I mean, I could show you the simple way, but let's show you how we would do it with an evaluator. So I'm going to rename this to find closest target. Now, normally when you're doing something like an AI being aggressive towards a target, it will be based off of a team ID. So you would have certain AI that have a team ID assigned to them, and then the players or another enemy gang of AI would have another team ID assigned to them. And then you would check their team IDs, and those will be marked as targets. In this case, we're just going to get locally controlled players, and only then will we mark them as targets. So we do want to get all actors of class. When this tree starts, we want to get all actors of pawn class, and we do want to store these here in a variable, and we can call this our target array. And we don't want to cache anything like this. And on tick, every frame, we will iterate over this array. And this only happens when we are in our React state, so it's not that expensive. So for each of these guys, we want to check, is it a pawn? Is this already a pawn? Oh, okay, it's already set to pawn. Okay, good. So in that case, we want to check, is this a locally controlled actor? If this is the case, we want to check our distance to, and we would actually need to grab this and get distance to, and the other actor would be this guy. And if this distance is less than or equal to our minimum reaction distance, so we'll make this a variable that we can set inside of the state tree. So if this value is less than or equal to our minimum reaction distance, we'll set this to 500 as well. Then we would like to set this guy as the target. Okay, so if this is true, we'll do this check. And if this is true, we'll set this. All right. So if this is not true, we'll go to the next. And if this is not true, we'll go to the next, and we'll find the one that's closest to us. All right, so now if we go and let's rename this output, this is actually going to be this target actor. So I'm going to put this in output, and then we're going to delete this spline actor. So we're outputting this target actor here. And we'll make this private, and then we'll make this instance editable so that we can change this reaction distance if we want. Another thing that we could do is actually cast our player, just so that these values add up. Cast this to the BP third person character, and we can get our sphere component right here. So get this sphere and get the radius, and then we would set this value here just so that our reaction distance is the same as our actual reaction radius. So we'll set this to not be instance editable actually, and we'll just set this directly from the player character. All right, so now let's go over to our reaction state and let us run this evaluator here. You can see state tree task patrol. We don't actually want this to be in the patrol folder. I would prefer it to be in the reaction folder. So let's go to class settings and let's say react. And let's say find closest target. And that is the display name that we want to see. Let me compile this. So react, find closest target, and we are outputting a target actor. And then inside of this puppy, instead of debugging, we would prefer to focus target. You can see that's in the patrol section, but I would prefer that to be inside of the react, and this will be focus on target. Let's just make sure that that name is correct. Let's go to react, focus on target, and then we'll bind this to our find closest target's target actor. And then whenever this state has completed, we'll go back. We'll actually say that this tree has succeeded here, right? So now what we should see is whenever we enter that focus or that reaction radius, our target should be set to the focus target by using this evaluator. So let's go ahead and see if this works. Okay, so I don't see us actually focusing on this target. So we probably need to do this check as well to where the actor that is coming out of here is not equal to our context actor. I don't know how this passes. I don't know how this is passing. Our actor is not locally controlled. It's not a pawn. Okay, so going back, save, and let's see here. We enter this state, and our target is unknown. So we have a null pointer as a target. Huh, what? Okay, so this is failing maybe because we're not being explicit. Ah, okay, I see the problem here. The other actor is not being compared. Let's take a look. It's still not turning to me. So that is a problem. And the other actor is not being set. Jesus Christ. Okay, here we go. Here we go. Okay, still nothing. If we go back to our React tree here on complete, when we try to focus on a target, even if this has a null pointer passed in, we say that the tree succeeded. And you can see that setting this tree succeeded means that this tree will no longer go back to the root or it won't do anything. It'll just be set as succeeded. And the only thing that'll be running is the evaluators. So if we complete this, I want to go back to the root, but I don't want to enter this state unless our object class is valid. So if this object from our target actor, so our target actor here, if this target actor is not valid, we will not enter this state. So there needs to be another state here that is a child of the root that says wait delay. Because if there's not another state that can get entered that could essentially transition us to the root, we will end up being locked essentially. So if this enter condition fails, we won't process any of the transitions, any of the tasks or anything. This will essentially get skipped. So it'll skip this if the transition fails or if the enter condition fails, and then it'll come straight here. What we want to do here is just wait for a small amount of time, like 1/10 of a second, and transition back to the root. And then this way I could actually set this to be tree succeeded if we ever get in here. So now if we go into this puppy, we should see this guy rotate. Okay. And it could be because we are still trying to process a move. So let me tell this AI controller to stop movement and then set its focus. Let's see if he reacts here. Nope, he's not reacting. Okay. Okay, so the reason that this wasn't working, the logic is actually working perfectly fine. We just weren't seeing our AI look at our player. The solution is to use controller rotation yaw, and I'm gonna uncheck this, and orient rotation to movement. So if I press play here, we'll run into his thing and he'll look at us. We are now his focus point, and now you can see that we are what he's looking at. And once we exit that state, what we actually want to do is make sure that our AI in its patrol state has no focus point. So our move to next point, actually we can do this inside the third person character. That way it's a little bit more, what's the word I'm looking for? smarter to do. So we can get the controller here and cast this to an AI controller and set the focus to a null pointer. So this way he doesn't focus on us anymore. He just moves the normal way that he should, or she should, they should. Holy fuck. Who am I? All right, so let's test this. We'll move in here and we'll move out and he'll go back to his patrolling. And if we move into his radius again, he'll focus on us. That is scary fast. I think the rotation rate can change that. So the rotation rate, if orient to movement is true, let's change this to like 90. 500 is kind of crazy. No, that's instant. Okay, whatever. It's somebody find the solution to how to make this guy not a goddamn jump scare. Jesus Christ, he's a robot. But yeah, that's essentially the react state. Now we're going to think about how we're going to implement the attack state. So I'll see you guys in a sec. Okay, so our attack state is going to be fairly simple as well. We're just going to use this sphere component to trigger everything. If somebody is in this reaction state, we're going to focus on them, and whoever is the closest will focus directly on them. But when something begins this overlap, we want to start a timer that will essentially count down to us attacking. So if we have something in here in our reaction, they're pretty much in our range to react. We could also, let's give this a name. Let's call this our reaction sphere or reaction radius. And what we could do is make another one of these puppies and we can call this our attack radius. And this will be for, let's say, for melee attacks for now, and we'll also make one for ranged attack radius, and we'll set the reaction radius to be something a lot bigger. So let's go to the radius. Let's set this to 1500. Our ranged attack, we'll set this to 750, and our melee attack, we'll set this to 500. So when we enter this, we'll enter this state tree for reaction. When we exit this, we'll exit this state tree and go back to patrolling. But when we enter this ranged attack radius, whenever something begins to overlap on this, what we want to do is set a timer by event. I'm going to use the helpful node to create an event, and we'll just create a matching function here. I don't want to do a function, actually. Let's delete this. Let's create a matching event, and we'll call this event begin attack sequence. This is the ranged attack. So in here, what we'll do is time before ranged attack. Set this to 2 seconds. So if somebody is in our radius for 2 seconds, we're going to attack them. And we're only going to do that if these checks pass. So we can actually collapse this to a macro. Should react. And let's fix this up here. Let's get rid of A. We don't need it. And let's output true. And let's output false. Okay, so we'll do this if we should react here. We'll start this timer, and then when we leave this, we'll end this timer. So this is our ranged attack timer. And in our ranged attack radius, when we end the overlap, we'll see if this timer is still active. If this is active, we would like to clear and invalidate this timer. And in this function, basically all we're going to do is this right here. Stop the logic, set the state tree, and restart the logic. Our state tree is going to handle the ranged attack. All right, so let's create our ranged attack state tree. All right, so I'm going to right click inside of here, add a new folder. Let's call this ranged attack. And like everything else, we're going to duplicate one of these guys into here. And we are going to rename this ranged attack. Okay. So we need an actor to spawn. I'm gonna just spawn a projectile. So let's just call this our BP projectile. We're not gonna do damage or any of that stuff. You guys can handle that on your own. I'll just show you representation of what's supposed to happen. Add a projectile movement component. Initial speed 4,000, max speed 6,000. And pretty much all we're gonna do is create a task that will fire one of these at the enemy. First, let me create the function here. We do want to spawn this out in front of us so that we don't get hit by it. And back to the projectile. We want the rotation to follow the velocity, and that should pretty much be it. So what I'm doing here is spawning this projectile in front of my player, using the player's rotation as a rotation. And I want to set this as the instigator. And I would also like to set it as the owner. And going into the task that's actually going to call this function, it's going to be fairly simple. So let's just create this task right here, copy it. We can delete all of this. And when we enter the state, what we could do is get our actor, cast it to our third person, and essentially tell this guy to fire the projectile. We don't need any inputs, so we can delete, delete, and delete. And then we can say that this task is finished. Now, I'm showing you a way to do this with the character, but if you were using gas, essentially you would get the ability system component and, you know, activate the ability. If you're using your able, you would activate an able ability. If you were using your own ability system, this is essentially you replace this logic with however you are going to fire your projectile. I just did a simple setup here. Now that we are having all the pieces that we need, I want to go to this range attack, and here we're just going to say attack, and we'll delete here. We'll just delete this guy. Once this attack has completed, which will be our, I think it's going to be in patrol. It's accidentally in patrol. So I'm going to move this out of patrol, and we'll set this into attacks, and we'll make one more folder and call it ranged. And this is going to be fire ranged attack. Going back to this guy, I'm going to close these because we got a lot of stuff open. Yeah, don't need that. Don't need this. Don't need this. And don't need this. Okay. So yeah, fire range attack is going to transition whenever it's complete to tree succeeded. And we can save this. This state right here is only going to be entered whenever the attack is here. Now, what we could do is repeatedly attack. Hold on. So I do actually need to go back to the third person character. And let's make a comment. Fire projectile from state tree. Come on. Bro, let me fucking grab this. Thank you, Unreal. Holy shit. Okay, so in here, if this fires, I would like to essentially loop this again so that it could be an automatic attack. So You can also make this an input on whether or not to do that. But just for this case, so I want him to continue attacking until the player leaves the volume or something else happens. So what I'm going to do is call this again and set this again. So we'll duplicate this. And every 0.5 seconds, we'll call this, set this, and this will get called again. So actually, we want this to call fire projectile. So fire projectile will get called, this will happen, and then fire projectile will get called. Now I could have this just loop somehow. So I could have fire projectile do this function right here and just loop. And instead of calling fire projectile, we will call shoot here. And we'll call shoot. And now this will just get called once, but it'll be set to looping. Okay, so we can actually see this in action if we set our state tree to ranged attack here. And I want to change the radiuses here. So the reaction, I'm going to change it to 1,000. The range, 750 is still fine. I think you can change the color of this shape. Yeah. So reaction, we're going to change this to yellow. Melee, we'll change it to blue. And then range, we'll leave it at red. Okay. So now when I enter this radius, he should react to me, or she. When I enter this radius, she should wait and essentially attack me. And then we are doing nothing when we enter this radius yet. So they react to me and she's firing at me. You can see it's continuously firing. And then once I leave that radius, she goes back to patrolling. If I go in here, she reacts to me. And here, all she's doing is shooting at me. Once we leave, she no longer reacts to me. And the reason that she's still following me here is because as long as I'm in here, I'm the focus target. Once I leave, that's the only time that I'm no longer the focus. I also need to set these motherfuckers to destroy themselves when they hit. So I'm gonna say on component hit. Let's just destroy actor. You would do something with damage here. If it was gas, it would be a gameplay effect. Your own solution, it would be like use point damage or something along those lines. But here, I'm the focus, and now I'm getting attacked. So this is how you would do a ranged attack. And I'm getting ranged attack as long as I'm in this range here. As long as I step out of it, I'm just the focus. And once I step out of the entire reaction radius, I am the nothing. She's just going back to her patrol. So now we got an AI that is reacting, range attacking, disengaging once I'm not there, but still like noticing me. And then once I get out of there, she's no longer worried about me. She goes back to her patrol route. All right, so I'm going to challenge you guys to create a melee attack. We've set up pretty much all the things that you're going to need to set up a melee attack. Essentially, you know how to move the player to a location. You know how to make the player look at something. You know how to make the player do something from an event inside a state tree. So when you come into this radius, the player should move to this target. It should also cancel the ranged attack. So when I come in here, I should set the state tree to do a melee state tree. The melee state tree should move me within a certain distance of the target, and then it should attack that target with a melee animation of some kind. So for my solution, I'm not going to use a melee animation. I'm just going to probably do like a jump or something like that to show that that animation would fire off. But I want to see if you guys can get it, and I'll see you in a sec. Okay, if you couldn't figure out the melee attack, it is not that tough. I'm going to show you guys right now. So I'm going to just create a new folder for the melee attack, and it is essentially a one-to-one clone with the ranged attack, except that we are not spawning an actor. So I'm gonna just copy these into here. I'm gonna change this to melee attack, and let's go execute melee attack. So in the melee attack, all we want to do is call execute melee attack, and in our third person character, we want to make sure that the melee state tree is active whenever we overlap this melee radius. So on component begin overlap, and let's go ahead and make it on component end overlap as well. So on component begin overlap, we want to do our check here. If we should react to this guy, we should react. We want to call this logic again, which we could probably collapse that to a function as well. So we can stop copying the nodes all over the place. So I am going to collapse to a macro as well. And we'll call this activate new state tree. And all this will do is take in a execution pin. And this will take in a state tree. And we could do like so. We'll do the melee, and then we can copy this in places where it'll clean up our graph. So we'll set this to ranged attack, get rid of these nodes. Same thing with this guy. This will be patrol, and same with this guy. This will be the react state tree. Okay, that just cleans up the graph a little bit. So yeah, if we should react, we'll activate a new state tree. That's the melee, and then we end overlap, we'll go back to patrol. This will actually send us back to patrol once we leave the melee attack radius, which could be a problem because technically if we leave the melee attack radius, we will be in the ranged attack radius. So once we end this overlap, it probably is just safer to go back to patrol. I'm not going to try to make this too complicated, but if you wanted to switch from melee to ranged, whenever they leave this, you know that they are still in this radius right here. So you could, and I'd rather just show you. So we'll just say is in range attack radius, and by default that'll be false. And we'll go back to our event graph, and when we overlap our range attack, if we should react, we'll set this to true. When we end the overlap, we'll set this to false. And then when we come out of this state, we'll actually hit a select here. And if we are in a range attack radius, we'll actually go to the range attack. If not, we'll go to the patrol. So now that we have that state tree activated, we need the function that'll get called. And let's do this as the melee overlap. We need that same functionality from here where we make a custom event that will try to melee, and this will set a timer by event, and we'll cache this as the melee attack timer. We also want this to set to loop, and this will call a new event called melee. And realistically, all we're going to do here is play a montage. You guys probably have a montage to play, but in this case, I am just going to create a montage out of the jump animation in the third person character. So I go to blueprints. We do have this jump. Let me go ahead and create a montage out of this. So let's just call this anim montage attack. Back to our third person character, and we can play that attack montage, and essentially every half a second. So we'll just set this to be like 1 second. All right. And so now we need to create a couple of tasks that will move our player to a closer position. So let's create a task. We can just copy this here, duplicate this, and then rename it to move to location. Once we enter this state, we want to get an actor and move to its location within a stop radius. So we need an input for that. So let's say that this is an actor object reference, and this is our target actor. And we need to put this in the input section. We'll grab this guy and we'll cast this to a pawn. Then we need to get the controller. Then I need to cast this to a AI controller. We'll move to actor. And I'm going to use the AI move to so that it could be asynchronous. Yeah, this one is asynchronous. So our goal actor will be this target actor, and our acceptance radius, let's stop them like 100 units away. And then on move finish is when we'll set this task to be completed and successful. And we need to cast this to a pawn. Okay. So in order to fill this input, our state needs to evaluate. So our melee state needs to evaluate a target. And we already have this function right here to find the closest target. And we can get this actor, and let's add another state. That's a child state. So we'll add this child state. The first thing we want to do is move closer to target, and this will run the task attacks, and it's in range, but we'll move to location. And then whenever this succeeds, we will move to the attack here. If it fails, we will go back to the root, which is fine. And once we get here, we'll execute the attack. On state completed, we'll say that the tree is completed. So this needs an input, and we can bind it to our target actor in our find closest target evaluator. We save that, and we should see that when we go here, he reacts. When we here, he's firing the bullets at me. And then when I'm here, he moves to me, and he's not executing the jump. I can still see him attacking me with the projectile. So there is some logic overlapping there. So one thing that's not happening is this actual attack, and that's because I believe this execute melee attack task, we didn't actually change it to call. There we go. We didn't tell it to try to melee, so that was why that was happening. We got the move to task, and then he started firing bullets at us. I was confused. So he should start firing bullets at us here when we're in this radius, and then when we come here, he should move to me and jump. But he's not jumping. He's actually still firing bullets at your boy. So try to melee. It's calling melee, which is just playing a montage. And our execute melee attack is calling try to melee. Let's go to our melee attack here. And let me swap this out and see if there might be some data that got tucked in there. And let's put a debug marker to see if this is firing. Okay, we do get here. We set timer by event, and it should wait 1 second, and then it should do this. Okay, we are doing this. But she doesn't play the montage. We don't have a skeletal mesh. So we need to pass this a skeletal mesh. Who caught that? So now we should get this. And they jump, and they jump, and they jump. So that will be called an attack. Once we leave this, we're still in the radius, but they don't stop jumping. So there are still some bugs here. Okay, so fixing the bugs. Whenever we disengage this, we need to clear and invalidate this timer because it's still looping. So if this is active, this is the case, we want to clear and invalidate it so that they can stop jumping. And we've already, let's comment this. This is our ranged attack overlap. What is this? Our reaction overlap? Okay. So moving in, he reacts, he starts firing. Come here, he stops firing. He starts melee attacking. I move out of this radius. He stops jumping. Now he's still focused on me, but he's still moving to the AI target. So hold on. I can see him still focused on me whenever he is supposed to be activating a ranged attack. Let me just organize this a bit. Okay, I'm seeing two things. When we enter this melee overlap, we should clear and invalidate this ranged attack timer. So clear that so that it doesn't fire anymore. Also, a thing that I'm seeing is whenever we leave our melee radius, we're telling this to activate a state tree based on whether or not we are still in the attack range radius. If it's true, we're telling it to go to patrol. But if we're still in the attack range radius, we actually want to go to the ranged attack. If it's false, that's when we want to go to patrol. So that's what's causing us to move around when we're not supposed to. So let's see. He reacts. He starts shooting me. He melees me. I leave this guy. He goes back to shooting me. I come in here. He stops shooting me. He moves close to me. He attacks. I move out of this, and he is firing bullets at me. I move out of that. He's still reacting to me. I'm still his focus target, and I move out of that, and he goes back to patrolling. So now we have an AI that has 3 different states based on 3 different collision radiuses. So there's a problem with which task is this. This is our shooting tree target, or shooting target actor. This one we don't really care about. I'm probably going to delete it from the world because it's going to cause issues. It's calculating component hit. So if my character hits it as well, it's still calculating the hit. So I'm just going to delete that. But yeah, now we have an AI that has 3 different states. One of those states is to patrol. Actually, it's 4 states. So he's got a patrol state. Then he's got a reaction state where he's reacting to an enemy that just entered their radius. He's also shooting at that enemy when they enter the range radius. And then if they enter the melee radius, he moves up to them and he hits them with the melee or jumps. So if we move out of here, we get hit with the ranged attack. And then if we move out of there, we're not getting attacked, but they know and we know that they can see us. We move out of here, he just goes back to patrolling. And I'm in his reaction radius. Holy, I didn't even see that. So now we can see how easy it is to set up certain things with state trees, how easy the states can be to set up, how even though it has a few objects that you have to maintain, and it could feel a little cumbersome. As long as you're organized, as long as you have states and tasks and evaluators that are doing one thing and one thing only and not necessarily operating off of multiple things, you should have a pretty performant and a pretty modular system. So what I mean by that is if I wanted to completely stop this guy from, if I want to stop him from doing ranged attacks, I wouldn't have to go to his behavior tree and disable the ranged attack from him. In this case, I would just take this ranged attack melee and deactivate this component, or I'd go set the auto activate. No, realistically, the solution would be to turn off the collision for this. So I would set this to no collision, and then there would be no ranged attacks. So if I go into the range radius, you can see he's not doing a ranged attack because the logic to activate the range state tree is no longer there. But if I move into melee, he has melee. And then you can see how if you wanted to make this a more public, like a designer friendly thing, you can have an enum that said, okay, I want this to be just a patrol actor, patrol and react, or a patrol and attack, or patrol and melee. So you could basically create like your own little AI based off of these 3 collisions. You can get more advanced if you wanted to. If you wanted to react to sound, we could have this reaction sphere overlap sound actors. And if a sound actor hit there, the AI would react to it as if it was a sound. You can get really customized with your systems. That way you don't have to use all of Unreal's built-in systems, and you can make it your own, really. So I hope that this was helpful.